In this question, we have two cars which are traveling at constant velocities. We have a red car which is traveling with a velocity of 25 meters per second and an orange car which is traveling with a velocity of 15 meters per second. We are told that the orange car is 10 meters ahead of the red car. And we are also told that at some point, the red car will pass the orange car. We can draw that on our diagram like this, because when they pass each other, they will be at the same position. And we want to know how long will it take for the red car to pass the orange car. The first thing we want to do when we're answering this question is write down what was given. We know the velocity of the red car is 25 meters per second. The velocity of the orange car is 15 meters per second. And just a note, throughout this question, I will be using the subscripts R and O to differentiate between the red and orange cars. Next, we want to look at the initial position of the red car and the initial position of the orange car. If we imagine this line as a number line, the red car is right at the start, so it is at a position 0 meters, while the orange car is 10 meters ahead, so it is at a position 10 meters, which means we can write XIR is 0 meters and XIO is 10 meters. Next, we want to ask ourselves about the final positions of these vehicles. If we look at our diagram, we see that when the cars pass each other, they are at the same position. This means we can write XFR is equal to XFO, which means their final positions are the same, so we can drop the subscripts and just write the final position as XF. Next, we always want to remind ourselves, what are we even solving for? We are solving for time, delta t, because we were asked how long will it take for the red car to pass the orange car? How much time will it take? Then finally, we want to look at the equations we can use to solve this. We were told that the cars were traveling with a constant velocity. When you see constant velocity mentioned in your question, think about uniform motion, which means motion with no acceleration. The cars are not speeding up or slowing down. So we can use the equation v is equal to delta x over delta t. And we know we can write this equation in its expanded form as v is equal to xf minus xi over delta t. Now we have two objects that are in motion, which means we need two equations. We need one for the red car and one for the orange car. The red car equation will be VR is equal to xf minus xir divided by delta t. The VO equation will be VO is equal to xf minus xio divided by delta t. Now that we know what we are given, what we're solving for, and what our equations are, let's make a game plan for answering this question. I always like to start by looking at my equations and asking myself, what can I plug into this equation and what can I solve for? Well, if we look at the velocity of the red car equation, we have VR and we have XIR, but we don't have the final position and we don't have the time. If we look at the velocity of the orange car equation, we have VO and we have XIO, but again, we don't have the final position and we don't have the time. So what we can see is that in both equations, we don't have the final position, and in both equations, we don't have delta t. This means we have two equations with two unknowns. So how do we go about solving this? Let's move to a clean sheet. I'll write out our equations again. So we have our VR equation and our VO equation, and we know we have two equations with two unknowns. So the question is, how do we solve this? So the first thing we want to do is isolate for one of the unknowns in the first equation. You can choose either of these equations to start with. I'm just going to start with the VR equation, but I could have used the VO equation and the answer would be exactly the same. And you can choose either of the unknowns to isolate for. But my advice is that you always choose the unknown that you're not solving for in the end. We know we want to solve for delta t. That will give us the answer to the question. So the unknown we want to isolate for is xf, the final position. So what I'm going to do is I'm going to isolate for xf in the VR equation. And now, once I've isolated for my unknown, I'm going to substitute the value of that unknown, which in this case is VR delta t plus xir. That is equal to our unknown xf. So I will substitute that into my VO equation. What I'm doing is I'm getting rid of the xf variable so that all that is left is one unknown. Once I've substituted what xf is equal to into my VO equation, what I'm left with is only one unknown, which is delta t. And that's the unknown I want in order to solve this question. The final step is to just isolate for our second unknown, which is this delta t. So all we need to do is rearrange this equation. In this case, I'm rearranging it so I have delta t isolated. My goal is to get every part of the equation that has delta t onto one side, and then common factor out delta t and rearrange to isolate for it. And at this point, we have all the information we need to just plug our numbers in and solve for delta t. To make things more clear, I'll move on to a clean sheet and we can just plug our values into our delta t equation. So we have delta t is equal to xir minus xio divided by VO minus VR. We know xir is 0 meters, xio is 10 meters, VO is 15 meters per second, and VR is 25 meters per second. When we do the math, we get negative 10 meters divided by negative 10 meters per second, which means it takes 1 second for the red car to pass the orange car. And that is the answer to our question.